Welcome to the Kentucky Safe Trenching and Excavations webinar. In this course, we will discuss the requirements for trenches and excavations. My name is Talia Martinez, and I'm a safety consultant with the Kentucky Labor Cabinet. If you have any questions or concerns after the webinar, you can contact me at talia.martinez@ky.gov. Our training courses are designed to assist you in complying with OSH regulations. Because of the variations that can occur due to on-site conditions and performance criteria, it's impossible for any course to cover every aspect of those potential variations. Therefore, this course does not cover everything a person should know about a particular subject, or does it qualify anyone as a competent or qualified person. However, our courses do cover part of the information that any person must know to be effective in applying safety and health standards and practices to circumstances in the workplace. The objectives of this course are to discuss potential hazards that are associated with trenches and excavations, the different types of soil classifications, the need for protective systems and examples, the current national emphasis program for trenches and excavations, and the requirements for emergency rescue from an excavation. Full regulatory standards, of which the information and requirements that are contained in this presentation can be found in 1926 Subpart P. All trenches are excavations, but not all excavations are trenches. An excavation is any man-made, cut, cavity, trench, or depression in an earth surface formed by earth removal. A trench or trench excavation means a narrow excavation in relation to its length made below the surface of the ground. Generally, the depth is greater than the width, but the width of a trench, when measured at the bottom, is no greater than 15 feet. With all excavations comes the requirement to have a competent person. Any excavation, regardless of depth, is required to have a competent person complete a daily or pre-entrance inspection of the excavation, adjacent areas of the excavation, and any protective systems that may be in place. The competent person will complete a manual soil analysis and a visual inspection of the excavation and the environment that surrounds the excavation. The competent person will determine if there is potential for a collapse. If there is a potential for a cave-in, then protection must be provided or installed before workers can enter the excavation. If an excavation is greater than 5 feet in depth, then a protective system is required. We will discuss those later. It is important not only for the competent person to know what to look for as far as potential for a collapse, but it's also important for the workers to know as well. When determining potential for a collapse, soil composition plays a crucial factor. The weaker the soil, the greater their potential for a collapse. Weather conditions are also a contributing factor for a collapse. If the weather has been hot and dry, the soil is impacted. This could weaken the stability of the soil. The same goes if there's been a lot of rain. This could cause runoff and erosion on an excavation, increasing the potential for a collapse. The environment that surrounds an excavation can contribute to a collapse as well, such as working near roadways or heavy equipment working around an excavation. Vibrations that come from vehicular traffic can cause a collapse, as well as other heavy operations that may occur near an excavation, like pile driving. When sloping excavations, soil classification needs to be conducted. Different types of soil require different types of sloping configurations. For example, type B soil can be benched, while type C cannot. When looking for potential for a collapse, a visual inspection is required. Visual inspections include looking for fissuring or cracking in the walls of an excavation. Fissures and cracks can identify weak areas in the soil, areas that would be more likely to cave in. When looking at the walls of an excavation near a roadway or building foundation, you want to look for undermining. Undermining is when excavation walls have been dug under existing concrete, asphalt, or other structures that could collapse. There are many potential hazards associated with excavations: falling objects, lack of access and egress, hazardous atmospheres, mobile equipment, and one of the more severe hazards, collapses or cave-ins. When workers are in an excavation, they are working below ground, which means that they are more prone to objects falling from overhead. Falling objects could be anything from soil and rock to materials, tools, and even equipment. Adequate protection is required to be provided to protect employees from loose rock or soil that could fall or roll from an excavation face. Workers are also required to be protected from excavated or other materials or equipment that could pose a hazard by falling or rolling into excavations. Another hazard associated with excavations is a lack of access and egress. Means of access or egress means a way in and out for workers. If an excavation is greater than 4 feet in depth, then a means of egress is required. This can be a job-made ladder, an extension ladder, stairways, or structural ramps, or even sloping the excavation at a 34-degree angle or less, so that workers can simply walk out of the excavation. If structural ramps are used, then they must be designed by a competent person. Means of egress cannot require workers to travel more than 25 feet laterally. If an excavation is greater than 4 feet in depth and there is potential for oxygen deficiencies or hazardous atmospheres, the excavation shall be tested before workers enter. If an atmosphere contains less than 19.5% of oxygen, then adequate precautions shall be taken to prevent workers from being exposed. If the atmosphere in an excavation contains a concentration of flammable gas, then adequate precautions shall be taken to prevent workers from being exposed. In the event that an excavation requires atmospheric protection, then the atmosphere will need to be tested to ensure that the control measures are maintaining a safe atmosphere. Though there are different situations that can produce a hazardous atmosphere, they are most common in areas where hazardous substances are stored nearby or in excavations that are in or around landfill areas. When an excavation is located near a roadway and workers are exposed to vehicular traffic, the workers must wear suitable garments. These garments should be made of reflectorized, high-visibility material. If mobile equipment is being operated along the sides of an excavation or is required to approach the edge of an excavation and the operator does not have a clear and direct view of the excavation, then a warning system should be put into place. A warning system can be flagging, a fence, a curb, or any other means that alerts the operator of the equipment that they are nearing the edge of the excavation. We talked earlier about potential situations for a collapse. The outcomes of a collapse can be detrimental, not only to the production of work, but also to the workers themselves. If a worker is caught in an excavation collapse, they can be victim to a variety of fatal health effects, such as blood clots, pulmonary embolisms, lacerations, abrasions, amputations, and suffocation. Workers are required to be protected from cave-ins except when the excavation is made entirely of stable rock, or when the excavation is less than 5 feet in depth and the competent person inspects the excavation and determines that there is no potential for a cave-in. Here is an example of how the competent person would determine if there is potential for a cave-in and if a protective system is required. A trench is 4 feet wide, 4.5 foot deep. During the competent person's visual inspection, he notices that there is some fissuring or cracking throughout the trench walls. Though the trench is less than the 5-foot minimum height to be required to have a protective system, during the visual inspection, the competent person determined that there is potential for a cave-in, given the cracking in the trench's walls. The competent person would then evaluate the situation to determine what form of protective system would be best suited for the trench. Given that the trench is 4 feet wide and other contributing factors, a trench box would be the best suited form of protection. There are different types of protective systems, such as sloping or benching, shielding, and shoring. Sloping and benching diagrams are located in Appendices B of Subpart P. The most common type of shielding is a trench box. These can be stacked if they're designed to do so. When using a trench box in all 3 types of soil, the top of the trench box cannot be less than 18 inches above the top of the vertical side, which means that the trench box cannot be below or level with the top of the excavation's wall. It has to be at least 18 inches above the top of the wall of the excavation. Shoring can also be used as a form of a protective system. This can be timber or hydraulic shoring. If a manufactured type of protection, like a trench box or hydraulic shoring, is being used, then the protection must be used in accordance with the manufacturer's requirements. There are appendices in Subpart P that are specific to each type of protective system, how to select and use a protective system. The appendices for trenching and excavations are mandatory. In 2018, the Federal Occupational Safety and Health Administration issued a national emphasis program on trenches and excavations. Given the high fatality and serious injury rates related to trenches and excavations, the National Emphasis Program increased an enforcement presence on trenches and excavations by consultants and compliance officers. The details for compliance, safety, and health officers under the National Emphasis Program include initiating inspections under the National Emphasis Program when they observe an active trench or excavation that's deep enough to present a hazard, regardless of whether or not a violation is readily observed. The observations that the compliance officer make can occur during the course of their normal workday travel or while they are engaged in program or unprogrammed inspections. The details for safety and health consultants under the National Emphasis Program include consultants initiating activity when they observe an active trench or an active excavation with a depth sufficient to present a hazard to workers. Consultants will address the hazards with the employer and instruct actions for abatement. If the employer does not remove the workers and abate the hazard, then the consultant will make an immediate referral to the Division of Occupational Safety and Health Compliance. When classifying soil in an excavation, there are three types of soil: Type A, Type B, and Type C. Type A is cohesive soil with an unconfined compressive strength of 1.5 tons per square foot. Some examples of Type A soil include clay, silty clay, sandy clay, and clay loam. Type B soil is cohesive with an unconfined compressive strength that is greater than 0.5 tons per square foot. This includes granular cohesionless soils such as angular gravel, silt, and silt loam. This also includes previously disturbed soils that were not previously classified as Type C. Type C soil is considered to be the weakest out of all the three types of soil. It is cohesive soil with an unconfined compressive strength of 0.5 tons per square foot or less. Type C soils are granular soils that include gravel, sand, loamy sand, and submerged soil. Type C soils are submerged and unstable and can be material that is sloped and layered in systems. Emergency rescue equipment such as breathing apparatus, a safety harness and line, or a basket stretcher shall be readily available where hazardous atmospheric condition exists or may be reasonably expected to develop during work in an excavation. Employees entering bell-bottom pier holes or other similar deep and confined footing excavations shall wear a harness with a lifeline securely attached to it. The lifeline shall be separated from any line used to handle materials and shall be individually attended at all times while the employee wearing the lifeline is in the excavation. Thank you for watching this webinar for trenching and excavations. Be sure to check for other free online safety and health trainings on kysafe.ky.gov.